Hi, I'm Wouter from Triply, and this is part 5 of my SPARQL tutorial. In previous episodes we've already performed several SPARQL select queries, but those SPARQL select queries always involved one single triple pattern. So this means that we were always matching exactly one triple from the knowledge graph. In this episode we'll look into generalizing that notion into matching not only single triple patterns but also multiple triple patterns. And this is called a group pattern. The best way to get into these group patterns is by starting out with a query that we wrote last time and then extending it. So this is one of the queries that we wrote last time, and as you can see, this consists of one single triple pattern. The triple pattern has three components, that's why it's called a triple pattern. It has a subject, a predicate, and a object term. And what this does, this retrieves all the Pokemons and their corresponding colors. Now we want to add another triple pattern so that we get a group pattern, or a collection of more than one triple pattern. And that's something you can see in this query. This query is basically the same as the previous one, in that it has the same first triple pattern, but it's also a little bit different because I've also added a second triple pattern. And there's something special going on here. Both triple patterns share the same subject term, so they both start out with the Pokemon variable. And this means something very specific in terms of SPARQL. This means that the two triples will be matched with the knowledge graph, but in such a way that they will always share the same subject term, so they will always be about the same Pokemon. This is a principle that is known in databases as a join, which means that you will be, in this case, retrieving all of the colors for each of the Pokemons. You will also be retrieving all of the cries of all of the Pokemons, and then you will be joining them such that all of the colors and cries will be about the same Pokemon. Let's see what results we get from this query. So this query result returns a table because it's a select query. Select queries always return tables. It has two columns corresponding to the two variables that appear in the projection. And these are Pokemons and cries of the Pokemons. And then we can see that here we have an identifier for a Pokemon, and here we have a literal. We can see it's a literal because of the quotes and then the two caret characters over here. So then we have a literal, and in the literal is contained an MP3 file, and the MP3 file is representing the cry of each of the Pokemons. And it's very important, of course, that the cries are the cries of this particular Pokemon. Here we can see it's quite clear because the name in the Pokemon identifier happens to correspond with the name in the MP3 file, which is indeed an indicator that we always get the cry that belongs to a particular Pokemon. That's very nice, but group patterns are even more general. We can add an arbitrary number of triples or triple patterns. So let's take a look at the next query. In this query I have added quite some triple patterns all about the same Pokemon. Starting out, I'm retrieving here the color of a Pokemon, then the cry of the Pokemon, and then the name of the Pokemon, and then two types of a Pokemon. Now there's a couple of interesting things going on in this query. First of all, notice that all of the properties until now have been starting out with the same IRI prefix. So they all started out with HTTPS, DB, Academy, Pokemon, vocab, which stands for vocabulary. So they all had this same prefix, but now we have this middle triple pattern. It starts out with a very different IRI prefix. And this is very normal in linked data, because in linked data everybody can publish their own vocabulary. Everybody can publish their own set of terms that you can use to describe knowledge graphs. So some of these terms are coming from this knowledge graph. Some of the terms are defined in the Pokemon knowledge graph. Those are the terms that start out with HTTPS, DB, etc. But there are also some terms that are coming from different vocabularies that have been specified by other people on the web. In this case, the IRI that starts out with http www.w3.org, etc. This IRI is not specified in the Pokemon dataset or knowledge graph, but it's instead specified by the World Wide Web Consortium, the W3C. And this is a standardization organization that has standardized RDF, the basic representation language for linked data. And what I'm here using is I'm using the label property from that external vocabulary. And in linked data, this is perfectly fine. You are typically not only using your own terminology, your own terms, but you are preferably also reusing other people's terminology. So in this case, you're reusing the notion of a human readable label as specified by the World Wide Web Consortium. And this is typically referred to in linked data as the notion of vocabulary reuse. So I'm reusing terms from somebody else's vocabulary. There's another interesting thing going on with this query, and we see that in the last two triple patterns, because the last two triple patterns have the same predicate term. So they both have this same predicate term IRI. They both have the type relation. And what this means is that we are basically retrieving two types. I've also called them type 1 and type 2. And these may be the same type, so it may be the case that I'm now pattern matching the same triple pattern twice. That's perfectly legal, nothing in the query prohibits that from happening. But it's also possible that I'm matching type 1 and type 2 differently. And that's specifically possible in case there are Pokemons in the knowledge graph that have two different types. So if I want to have this in a more specific way, so if I, for instance, want to exclude cases where type 1 and type 2 are identical, I must explicitly filter those out, but filters will be handled in a later episode. Let's take a look at the results of this query. So this query has quite a lot of variables corresponding to the fact that we have quite a lot of triple patterns. And here you can see that in type 1 and type 2 we have several unique identifiers. And for the first row, corresponding to the first SPARQL result, you can see that a Pokemon called Obama's has two types, the grass type and, again, the grass type. And this is possible because type 1 and type 2 are allowed to match exactly the same triple in the knowledge graph. But you can see that I have a different result over here, result 2, where it has matched both the grass type and also the ice type. And then, of course, I can also switch it around. If I'm able to match the grass type and the ice type, then I'm also able to match the ice type and the grass type. There's a final detail that I want to highlight with this query, and that's that I'm not including all of the variables in the projection that also occur in the group pattern. So specifically, this Pokemon variable is only used to tie together all of the triple patterns. It's not itself exposed, it doesn't reappear in the projection. So this means that this notion of Pokemon, this variable term Pokemon, is only used to ensure that there will be a join of all 5 triple patterns, but the Pokemon node itself is never returned in the query result. So what we saw in the previous query is that we had 5 triple patterns. It's exactly these 5 triple patterns. But they were all about the same Pokemon node. They all had the same Pokemon variable in their subject position. And we also learned that this is very important because that means that you can actually perform a join on that Pokemon node, and that guarantees that all the other variables will be about the same Pokemon. But in this query, what we add to that is 2 additional triple patterns that are not about the Pokemon, but that are about type 1 and type 2. So you can see type 1 over here reappears over there. So what we're now doing is we're not only applying different triple patterns to the knowledge graph all surrounding the same Pokemon, but we're actually querying for a type of a Pokemon, and then we're querying for the type name or the label of that type. So we're actually making 2 hops. We first take a look at what is the type of this Pokemon, and then we want to take a look what is the label or name of that type. If we now take a look at the result table of this query, we will actually see that there are two columns called type 1 name and type 2 name, and they now contain strings instead of IRIs, instead of universal identifiers. These are now simple strings. And there you can also see that sometimes we have the same type twice, as we saw in the previous query, but sometimes for this Gastrodon Pokemon, we have a water type and a ground type, and then also the other way around, also ground type and water type, because if we can match it in one of the orders, then we can also match it in the other order, as we saw before. And then scrolling back to the top again, what you can also see is that type 1 and type 2 are not part of the projection, so they are not exposed outside of the query. They are similar to the Pokemon variable, they are only internal to the query. Okay, so I hope you now learned how to generalize the notion of a triple pattern as what is called a group pattern. With this you can make very powerful queries. You can retrieve multiple properties about the same node, performing a join in the query engine. But you can also traverse the graph, so you can also do multiple hops, and in that way you can retrieve an arbitrary pattern from a knowledge graph. So this is clearly a very powerful construct that you can use in many applications. Okay, while writing these last 2 or 3 queries, what you also saw that I'm writing quite a lot of stuff, because I have to use all of these IRIs in linked data. The query gets very long, and it also becomes difficult to read and difficult to maintain. So in the next episode, I want to look into several abbreviation approaches that have been introduced in SPARQL, specifically to make the queries shorter, more readable, and also easier to maintain. See you then.